Hey everyone, welcome back again to Game5D. In this tutorial series, we are going to learn about the Poke interactions using Meta SDK and Unity. Within this tutorial, we are going to learn about how you can set up the Poke Interactors for controller and hand, and how to set up your own Poke Interactables. We're going to see all the scripts and go in depth to learn about how the Poke Interactors actually work, and how you can also set up your own Poke Interactable visuals to make it feel like how you want to be. We are also going to learn about how you can get access of the interactable events for each of these interactables and how you can go about it. So watch till the end for an in-depth explanation, and let's get started. Alright, so we begin with the same project that we had from the previous videos. If you haven't watched any of the previous videos, do watch them first to understand the current project state. So we had set up our OBR controllers and OBR hands in those videos. Okay, let's add the Poke Interactor by searching it in the project view, and make sure you search in packages and click on the controller Poke Interactor. Do keep a note that this prefabs comes with the Meta XR Interaction SDK under Runtime and Prefabs folder, and there will be a Poke folder under which you will find all these prefabs. Let's add the controller Poke Interactor by expanding the OBR controllers controller interactors group and dragging and dropping it into the group. Make sure that the controller ref are set correctly to each of the controller, and then we add the Poke Interactor to the paste over interactor group to dynamically switch the appropriate interactor based on the interactions. Okay, so the main script that does all the work is this Poke Interactor script, which has few of these values, but one major thing you need to keep in mind is the point transform. And the point transform is the particular transform which will be interacting with the interactable. Underneath the optionals, we all have the usual optional fields to add an interactable filters. Make sure the active state is assigned if you want to have an optional active state tracker there. And the poke location itself consists of a script called controller pointer pose, and to have a visual of it, Meta gives you this particular sphere mesh renderer. You may want to keep it, or for now I will keep it. If you want to disable it, just disable the mesh renderer. But the main script that does all the work is the controller pointer pose, which creates an offset of 0.01 centimeter in front of the controller, from where we will be able to interact or poke an interactable. Okay, with that said, let's add in the hand Poke Interactor. In the same way, we'll expand the hand interactors, then drag and drop the hand Poke Interactor onto the group. Make sure the hand ref are already set, and then add in the interactor to the based over interactor group as well. So similar to the controller Poke Interactor, we have the same script here, Poke Interactor, but instead of taking a controller pointer pose, this takes a transform called hand index fingertip. So the hand index fingertip contains a script, and this script is a hand joint script that comes from the interaction SDK, and the hand joint script is set to select the hand index 3, and these are all the bone names that we will find from a meta hand. And to show you how it works is that if I expand the hand visuals that we have, for example, let me expand the hand visuals left, go into the Oculus hand, expand the wrist, and then we have the index 1, middle 1, pinky, ring. You understand that these are the bone names for the fingers, and we need to search for the hand index 3, which will be a chain underneath of index 1, index 2 and index 3. And this is the bone that actually the hand joint is giving us using that script. And if I zoom a little back, you can see it is pointing, or it is in the index finger on the left hand. If I pull it up above the ground and select the bone again, you will see that it is indeed selecting the last bone on our fingertip. But although it's not the actual particular transform, we also have a local position offset of 0.017 meters. That means it will create an offset from the bone position towards the finger tip on the x-axis. So that's our particular transform, which will be interacting with the Poke Interactors. So if you want to have some other customized location, you can change the offset according to your hand models. For example, let's say if you have a larger glove or something on the hand and you want the Poke Interactor to react from the tip of the glove, so you can adjust the offset from there. Alright, so with our Poke Interactor setup, now let's set up a Poke Interactable to test with or see our Poke Interactors work. So I will drag and drop the Poke Interactable template prefab that Meta provides us in the same folder as of these Poke Interactors, and I'll set it up on the table that we have in the scene so that we can have a quick build and test it out. And for some reason the Poke Interactor is really small. I think that is intentional, but we can make them large. I'll make it to 10 cm in all dimension. Okay, to give you a brief overview of how the template has been set up, is that the template contains these tiled game objects and then Poke Interactable script on the root object. And the Poke Interactable script, similar to other Interactable, contains the max selecting and max interactors field. It also contains a pointable element. In case you want this Poke Interactable to be grabbable or something, you can drag that interactable or grabbable object as a pointable element there. But the main thing you need to note is the surface patch, which contains a clipped plane surface, and that is pointing to this child game object, which works by creating an infinite plane surface using the plane surface game object that has been clipped using this bound clipper to match our Pokeball interaction size. And to show you how it works, if I click on show surface visuals and I enable the gizmos on the scene view, you see this large infinitely extend plane on the view, and there is a square or drawn to it, and that's the bound clipper set to match our interaction size. So if you want to have a larger interaction or a smaller interaction on the poke, you can increase or decrease the size on it. So for now I'll just leave it to be 111 because that matches to our size of the poke interaction that we have as the quad. And you also can scale it. For now the plane surface is scaled to 001, but if you make it 1, you would see that this is indeed a box bound clipper, which is kind of hard coded to work on a plane by setting the scale on Z to 001. So the surface is the main interaction reference for the Poke Interactor to work. And if I select the Poke Interactable again, now that we have the gizmos enabled, you would see this circle and this cross appearing on the interactor or in the Interactable, and the cross always exists on the plane surface. It doesn't go beyond that because that's our maximum push limit or poke limit we can poke this circle into. So the circle defines our pokeable area, and there are certain scripts that you can also change to get an event for an hover. For example, this hover normal determines the distance from the plane surface along the normal, and that is the distance the current poke interaction or the circle is appearing at. You also have this min threshold enabled by default under the Poke Interactable, which defines the minimum area that you have to surpass along the normal before the hover interaction is set up. So we will see how this all works when we start stepping our or creating our own custom visual. But for now, let me show you how the Poke Interactable actually move. So the Poke Interactable uses this script called Poke Interactable Visual, which take the surface as the base transform. That's the maximum base that the button can be pushed into, and it contains, the visual contains itself a quad and few of the utility script that Meta provides to change or modify the color on the material and the look of the quad that you can edit when the poke interaction happens. So for now, let's do a quick build. Alright, so as you can see, we have these pointer or the spear appearing in front of the controller, and we can poke the interactor using our controller as well. Although one more thing you notice that the hover event doesn't actually appear before we push the button. It actually appears after we push the button. Let's test out our hands. You can see we can poke using the index finger, which works. And if I don't use my index finger, I cannot poke it because the hand joint is required to use the index finger to make the poke interactions. Okay, so in order for the hover interaction to work properly with the new Meta XR Interaction SDK, so if you have the main threshold enabled, the easier way is to just add the minimum value that is provided to the hover normal, so that the actual position of your poke interaction just move ahead of the normal in the normal direction around the minimum threshold value. And to show you that indeed that fixes the hover interaction, let me just change the hover color to somewhere to blue, and also to select color to somewhere darker blue. Let me select, let me make it a darker blue to see the interaction on the material. Also just go back and double make sure that you have copied and pasted the minimum threshold value and added it to the actual hover normal that already been set. Alright, so now you could see as I'm moving our controller near to the poke interaction button, even though before touching it, I can still see the hover interaction happening. And once I start pushing it, the hover event stays on until I reach the max post limit, which is the select event. And as soon as you leave the select event, the hover interaction take over, and that's how the hover interaction work in the Poke Interactables. So to have the actual hover event and to show you that it is indeed walking from a distance, let me just move my camera a little bit side, so you can see before touching the button, it's having that hover event getting invoked on, and as soon as I push it, the button will turn blue as soon as it reaches the maximum limit. Okay, so now let's understand how the Poke Interactable script does work. So as I said, the plane surface is important for the Poke Interactable to work, and the reason is that all these values that you set over here is relative to the plane normal. And for example, the hover tangent determines like how far you have to be reaching out from the sideways of a surface in order to enter into the hover state. Same goes for the hover tangent, hover normal exit and hover tangent exit. So each of these has a tooltip assigned. If you don't understand them, you can just hover your mouse pointer on them to understand what they actually means. But most of them are pretty descriptive from the name of them. As you can say, like cancel select normal and cancel select tangent. So these values, as I said, is dependent on this plane surface, and you would see that the plane surface has its own settings. For example, the facing is set to backward because we want the poke interaction to happen in the backward direction. If you want, you can set it to forward, or if you want the poke interaction to happen from both ways, you can select the double-sided option here, but I will leave it as backward because that's what we are going to mostly use with. Okay, the other settings that we have is important for you to understand. So that the drag threshold is useful for distinguishing between a press and drag events, and if enabled, it will automatically disable any move pointer events you may have on the poke interaction. For example, if you have the button pressed and you drag while your fingers or your controller on the surface, then this will suppress any move event trigger, and it will create the drag movement alongside on the surface based on these ease curve that is assigned at the bottom. Next, we have the positioning pinning. So what this does is that it creates a surface motion on the, like if you have the drag enabled, and if you want to have some sort of friction assigned to your hand controller or to your hands or controllers, then you can have this enabled. And while enabled, and if you have your button poked all the way through and you drag your hand, it applies a friction on top of your controller so that your controller or your hand doesn't move as smooth as it should be. So it will create a kind of friction so that there will be a delay when you move your hand on the surface. So sometimes required or sometimes doesn't, so this is disabled by default. The recoil assist is something that is new, I think. So what I find this is useful is that, for example, let's say you are trying to reach or press the button from behind of the plane surface, and you don't want that to actually create a pokeable or push on the button. and the recoil assist helps you with that. So what it will do is it will create an animated button press, but it won't allow you to select that poke interaction when you try to poke the button from behind of the surface. So that you can check there. And the optionals, again, similar to all other interactable, allows you to determine what kind of interactors can interact with it, with interactable filters and other options. So by default, with the template, you only have min threshold and drag threshold enabled, but you are all this recoil assist and pinning, positioning pinning is optional. Okay, coming back to the button visual, as I said, the surface is currently the base of the button visual. That means the poke interactable visual will only allow to push the button as far as the surface goes, and that's because on the button visual, the button based transform is assigned as the surface. So that's what that's what is being used to determine what the base of the button is. But if you want, you can still have a separate transform that can go beyond the surface and use that as a button based transform if you want the button to be pushed beyond the surface. So you have your flexibility to adjust that, but most of the time you should be fine using the surface as the base transform. And then these are the, as I said, these are the default property blocks that Meta provides to update this quad mesh that they have provided. So they use this shader on the material, and you can adjust the radius on the side to make it more roundable, and the interactable color visual is what we saw already. Alright, now let's move on to the fun part where we will customize the Poke Interactable with our own button visuals. So what we're going to do is that we have the surface transform, which is actually been used by our Poke Interactable visual to act as the base transform that our button can move onto. I mean, we cannot go beyond that. So we'll create a base as a child of the base transform. You are free to move it out of the surface transform and position it according to your whatever you want to decide, but I find it useful to make it as a child because I can then take advantage of the scale of the surface to position my visual accordingly. And as you can see that I'm scaling the button based visual to around 180 or 200 units. For now I'll make it 180. I think that should be enough. And even though I'm making it 180 in meters, due to the scale of the surface parent transform, which is set to 001 on Z, that translates to 1.8 centimeter in meter units, in unity units. And the reason I made it as child because that creates the surface. So let me make it 200 as a whole number. That creates the surface in the middle, and if I have to move the visual, I just need to have the scale, and that should do it, and move the surface onto the surface of that visual. So surface transform onto the button based visual, but I want to have some sort of lip on top, so I'll have that kind of so I'll just move the surface a little bit back so that the surface transform actually exists inside of the button based visual. So I have this material already created, which is just a black material. I will apply it on the surface just to have a visual aesthetic, and we can scale it a little bit so that our button can stick button doesn't take all the surface visual that we have. So 1.5 would be okay. Alright, so this looks really good. And now let's move on to the button visual. So as you know that the Poke Interactable visual is the actual transform that moves in and out in the Poke using this transform. So if you want to create a button visual, that means you have to make it as a child of the button visual. I mean this is necessary in here. Unlike the surface visual, the button transform or the button visual that you have needs to be a child of button visual. So we'll disable we'll remove the box, the collider on it, and since I'm using a cylinder, I will just make it 3 centimeter or 30 centimeter on the y-axis and rotate it along the x-axis. So currently I'm seeing the global gizmo. If you want to see the local direction, you can hit local and move it accordingly. But doesn't matter because the button visual is the one that's going to move in and out. And And in order for the button to completely go inside, the button parent or the Poke Interactable visual needs to exist on the surface of whatever button you are creating. So I'll adjust the cylinder and move it in such a way that the button or the Poke Interactable visual or the parent exists on the surface of the cylinder, so that the whole button will look like it's being pushed through. So right now, as you can see, I made it, so I position it in such a way that the button visual exists on the button surface. And as I said, this is the one that's going to move and not the cylinder that we have. So the button visual is the one that's going to move till the surface or the button base surface or transform. Okay, I still have the cylinder to just have a little bit of lip while being all the way pushed through. So what I'll do is I'll just have the cylinder moved a little bit away, like for behind of the surface, and the actual button visual will exist at a distance, so that I will have that portion towards the left sticking out of the base transform once being pushed through. And once we have set it, we'll disable all the mesh renderer and all the property that changes the mesh renderer. Okay, the next thing that we have to adjust is this poke hovering. So right now this is using the quad that we already had, but we want the cylinder to be the new visual. So what I will do is I will adjust the hover by adding the same amount, for example the mean normal again, so which is 0.015, and that will actually stick the actual hover surface beyond the surface of the visual that we have, so a little bit away from the surface. So that means the hover should act on the new visual that we have. And this is again another way I'm showing you how you can adjust the settings based on the customized version of your like whatever customized button you may have. The last thing we're going to do is we will assign an interactable debug visual to the cylinder, because we want to update the cylinder material. So assign the interactable view, which will be the Poke Interactable, and the mesh renderer of the cylinder, and change the select and hover color as per your need. I like the blue color, so I'll just place it blue, and that's pretty much it. So I'll just reiterate again. So what we have done is that, so if we go back again to the Poke Interactable, so we created this hover normal so that the hover normal sticks outside of our new visual and not outside of that quad that we had earlier. So that means when we push through, we'll have the hover event as we want it to be, like the normal hover event according to the new visual. We've also disabled this mesh renderer so that the quad doesn't appear, and we've also assigned interactable debug visual. Alright, so we got a customized button, and you could see it's floating in the plane, but that's fine. Okay, so as per our setting, I would expect the hover event to trigger before I touch the poke button, and which is indeed what's happening. Before I touch, it does create the hover event, and once I start pushing it through, it goes in as we expect, and once done, it's sending the select event or creating the select event. And one more thing that you would notice, that the button doesn't go all the way through, because we had the Poke Interactable visual sticking a little bit inside of the button, and that's create that visual of not going through all the way. We can again test it with the poke finger, the hands, and it does send it through from the poke button, and it's behaving the same way as it did with the controllers. Great. Alright, so now that we have created our first Poke Interactable visual, let me show you one common mistake most of the developers I have seen doing. Is that, for example, let's say if you want to have a Poke Interactable button in your scene that you can move around or grab with your hand, like you want to have a grab interactable on it, and also like you want to position it anywhere in the world, just drag and drop. Think of it like a remote controller. So the main thing that most of the people don't understand, that they change the rotation on the actual root transform, which will create a lot of unintentional rotational offsets when you try to apply any other grabbable onto the Poke Interactable. So what I would suggest is that instead of changing or modifying any values on the root transform, what I would suggest to do is to create a separate root transform as a child of the root, a child transform as a child of the root, and position all the model and surface inside of the transform. For example, let me just drag and drop it. In this case it won't allow me because it's the hierarchy bin set and the prefab. You can unpack it, or you can create a different prefab variant out of the Poke Interactable template, but for now that works. And you apply the rotation or any modification to the child transform of the interactable and not on the root, so that now your Poke Interactable transform stays clean, and you can apply any other grabbable or other interactable scripts on top of it, which will modify the rotation, and that won't give you an offsetted rotation, and it won't behave differently as you intended it to be. So again, another tip that you need to keep in mind, and if you want to have multiple interactables on it, it's better to stay clear of any transform variables on the root. So now I have changed the button to be red, and let's see that in action. Alright, we got our build out, although I forgot to mention that I kept the Poke Interactable visual enabled. As you could see, the translucent quad, and the Poke Interactable visual transform is the one that travels all the way through until the surface space transform. And since the Poke Interactable visual is beyond the surface of the button, that's why the button sticks out when it's maximum pushed down. And indeed, both the horizontal and vertical ones worked as expected. Also, the hover events are being fired before I touch the button, and I can push, as you can see, using the hand controllers as well. Again, one more thing, you can still access or select the button from negative direction, as I can show you. And if you don't want this to happen, you can have the recall assist enabled, and that will stop the button to sending the select event. Okay, so one more thing that you must have noticed is that when we try to poke with our hand, the hand doesn't stop at the poke interaction button, and it goes all the way through, which doesn't seem natural. And we already had this in the previous Oculus interaction SDKs, but in the new one you have these prefabs which we added for the Poke Interactor, and underneath that prefab I showed you these visuals. So let us enable this hand poke limiter game object. And this hand poke limiter visual script requires something called a synthetic hand, and it will automatically assign the hand reference and the Poke Interactor reference. But for synthetic hand in the manual template, the way we added is the OVR right hand visual, and that doesn't contain the script or the synthetic hand on top of it. So let's add another prefab called OVR left synthetic or right synthetic. You can search for anything, and this prefab, make sure you search for in packages, and this prefab exists in the Meta XR interaction SDK OVR integration package, and not the simple Meta XR interaction SDK package. So if you don't have that prefab in your project view, make sure you have the OVR integration Meta XR interaction SDK. So let's drag and drop the left hand synthetic onto the hand visual left, and the left hand synthetic does contain the synthetic hand, but it will also contain the same hand visual that we added earlier. So to not have any duplicate, we can what we can do is we can just disable the previous OVR left hand visual, and the synthetic hand visual will take whatever the child hand visual is there. So let's disable the OVR left hand visual, and the synthetic hand. Okay, let me add the right one as well before I explain anything, and disable the right hand OVR visual we had earlier. Okay, so the synthetic hand requires some data in order to update the synthetic hand. And if you remember from the very first video where we added this left hand and right hand, we had this hand script which again works in the similar way, which requires the hand filter to update itself or the data. We can either use the hand left, or we can use the left hand itself, which is again getting all the data from the hand filters. We'll apply the update after and data modifier to use the left hand data that we are getting from the hand script, and make sure to update or set the update mode to select after previous step and not Unity late update. If you use Unity late update, it may work, but you may see some sort of delay when the actual finger interaction shows up on the app. and that's because the late update works in a different step, and after previous step make sure that once we have the hand data applied, we get it as soon as the hand data is done or the hand script is done for it. So again, after previous step, and make sure the apply modifier is checked, because we are going to apply the data or modify the data for the synthetic hand. So again, drag and drop the right hand onto the right hand synthetic, and that should allow our synthetic hand now to read the hand data from the respective hand script, and it will move the hand or loop the hand as usual. The last thing we have to do is to apply the synthetic hands to the hand poke limiter fields. So make sure you drag and drop the right reference for the left and right synthetic hand onto the hand poke limiters. Alright, so with that done, another thing that you would see is that if I enable the visual, is that this hover or overshoot glow, which will require some other fields that you may assign, and I'll show you why I'm not enabling it here, because we will see that in the building blocks, because the building blocks already have them enabled. But if you want, what you can do is all these fields that is required are already available under the hand visuals. So for example, the hand visual, you can just drag and drop the hand visual from here under the synthetic hand. The next thing that you are going to need is a mesh renderer, shared mesh renderer, which will be under the hand visual. And the third thing that you need is the material property block editor, and this also exists under the hand visual. Click on the mesh renderer, share mesh renderer. Yeah, that's the share mesh renderer, and it should be on the share mesh renderer, and that's the script you can just drag and drop onto the overshoot glow. And the difference is very subtle, and it's very hard to show. So I don't prefer using it, but I will show that in the building blocks video. Alright, so we got our limiter set. Let's see in the action. Okay, now let's see the Poke Interactable, the Poke limiter or hand Poke limiter in action. So as you can see, now I'm pressing with my left hand, and I'm pressing really down, and if I move away from the clip plane surface, you would see that my hand is actually under the button, but the poke limiter is limiting the hand visual to stay on the poke surface or the interactable surface. Same thing on the interactable horizontal. If I move it out of the clip plane surface area, you will see the hand is not going beyond the Poke Interactable, which is really neat. Alright, now let's see what's the easiest way to create this Poke Interactables using the new building blocks the Meta provides. Okay, first let's disable the manual interactions and interactables we enabled. We had it disabled, and enable the building block interaction, which contains the previous interactors we added through building blocks. So if you haven't again watched the previous videos, just go over that so that you will understand how to add them. Alright, let's open the building blocks tab, and what you should see is this pokeable item, although it is experimental. If you have all-in-one SDK enabled, you may have to search for it, because there will be a lot of building blocks, and once you search for it, you just have to click on the button, add button. Let me just disable the interaction so that you would see cleanly what it adds. Okay, once clicked, you would see that it adds this pokeable item interactable, as well as in left and right poke interactors onto the left and right hand respectively. And the right poke and left poke is exactly the same as we added as the Poke Interactors, but with this building block script assigned. And the pokeable item is again exactly the same as of the Poke Interactable template provided to us by Meta Interaction SDK. So if I show you the model and visuals, it's the same structure. Again, the button visual is the same, although again same setup script, although the rounded box property doesn't apply any radius. You can apply it to it if you want. Again, the same script as I was saying as of the manual ones. So the interactable color visual again is the same script, but all with different set of colors now assigned. Even with the right poke and left poke, double make sure that the reference to the hands are correct. I mean, that's a good practice, you should follow that. And as I was saying in the previous one, the hand poke limiter is already set, as well as the hand poke overshoot glow is also set, and we will see that in action how that overshoot glow looks like. Alright, so we have our interactable and interactive setup for the poke using building blocks, and you could see how easy it was just to click on the add button on the building blocks to have everything set. Also double make sure that the surface on the pokeable item is again assigned, and since it doesn't have a mean threshold, so the hover will be around 0.03 centimeter away from the plane surface normal. Alright, so the building blocks poke interaction works the exact same way, but it's much more easier to set up now. And to show you the overshoot glow, what we set up earlier is that once I push all the way through in the button, you could see the white on the fingertip. So let me push it with my right hand. You could see the fingertip is going to white, and as you push through, the white will get more saturated on the fingertip if I compare to my left hand. So that's how it works. Okay, so as part of a bonus tip, I wanted to have this in a separate video, but I figured since I'm getting a lot of comments from people like figuring out how to get the actual interactable events, like when a poke interactable is selected, or doesn't matter what interactable it is, when it's being hovered on, when it's being selected. So the way you can access is that there are multiple ways you can define, but the easiest way is to make use of this interactable Unity event wrapper by dragging and dropping the interactable view, and that exposes these Unity events for you. And the way it works is that if you open up the script, it will take some time on my machine though. So yeah, so the script is open. So the way it works is that it's again from the Oculus interaction package. It's a mono behavior, nothing fancy. So what this script does, it reads from the interactable view that we assign. For now I'm assigning the poke interactable view, and it takes a type of interactable view interface, and it also has this Unity event that we saw on the inspector. And the way it works is that it subscribes to this interactable view individual events. As you can see, it subscribed to them with these callbacks, and within these callbacks, what it actually does is that it checks for the state, and which is called an interactable state, and based on these states it fires these Unity events. And that's basically what the interactable visual or the viewer or the color visual does. So if I open the interactable debug visual, you see that again this takes an interactable view, which we will drag it with poke interactable or grab interactable, anything, and it casts it to the interactable view, and again it's subscribed to the same when state changed, and listens to the state values inside of this switch statement and just changes the color of the material. And that's how you can actually access the interactable view states and use it according to your own script and own project architecture. Alright guys, this would be it for this video. I hope you found this video insightful and informative. It should give you an basic information regarding how you can set up your own poke interactions in your VR app. So if you found this video interesting, or you find these kind of tutorials interesting, make sure you leave a like, and also if you have anything to ask, please leave them in the comment sections below. I would love to go over them and reply to each one of you to help you create your own VR app experiences. Again, if you haven't subscribed to the channel, please consider doing that. That will not only help the channel grow, but will also create or motivate me to create these kind of videos more onwards in the channel. With that said, I'll see you in the next one.